All right, guys, let's put the Chromebooks away. If we have time, once we get finished, you can pull them back out. But till then, homework questions. What we're looking at today is dividing rational expressions, dividing two rational expressions. And the big difference between dividing and rational expressions is about 2 steps, or one main step. Because when we divide two fractions, we keep the first one the same. We change the sign from division to multiplication and flip the second. That's it. That is the only difference between division and multiplication. Well, there is one other, and we'll point it out here in a second. Because when we divide two expressions, the first thing we should do is keep the first one the same. Change the sign. Change our operation from division to multiplication and flip. Our second expression. Keep, change, flip. Keep, change, flip. Questions on this so far? Now from here till we get to the end is exactly like we did with multiplication. Once we do the keep, change, flip, we do this exactly like multiplication. So our next thing is going to factor. Well, the numerator for the first expression, 7x, is 7x. Because it's a single term, there's no way to reduce it any further. We can look at the denominator, 2x minus 10. 2x minus 10, the degree is 1 because x to the first. So we can't have our two sets of parentheses like we do for quadratics. So we look for greatest common factor, 2, and we can factor it out. Because if we factor a 2 out of 2x, we have x. Minus, when we factor a 2 out of 10, we have 5. And that's it for the first expression. Now, when we look at the other expression, we do have a quadratic, our x squared minus 11x plus 30. And we have our denominator, x squared minus 6x. Out of those two, I think it's going to be easier to factor the denominator. Because if we look at x squared minus 6x, we have a greatest common factor of x. So we can factor it out. And when we factor an x out of x squared minus 6x, x squared becomes x. 6x becomes 6. Now, just because it has a greatest common factor of x doesn't mean it's officially done. But if we do look in the parentheses, x minus 6, the degree went from degree 2, x squared, to degree 1, our x. No other greatest common factor, so it is done. Does that make sense? Which leaves our numerator, x squared minus 11x plus 30. There is no greatest common factor. One of the giveaways is the fact that the number in front of x squared is 1, and our third term, 30, does not have a variable. So there's nothing we can take out of all three. So we can factor it. 30 is positive, so the signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared are x and x. Now factors of 30, 1 and 30, 2 and 15, 3 and 10, 4 does not work, 5 and 6. 5 and 6 would be nice, yes? Because no matter how I put them, if we put 5 and 6, I now have an x minus 5 on top and bottom. I now have an x minus 6 on top and bottom. So it would work out very nicely if this was the case. And if we do check this here, x times negative 6, negative 6x. Negative 5 times x, negative 5x. Giving us the middle term of negative 11x. So it is correct. Now, the last thing we need to do is multiply these together and simplify. On top, we have 7x times x minus 5 times x minus 6. The denominator, we do have the 2, but we do have another monomial term to go with it, which is x. We move the 2 and the x to the front. because we are multiplying these together, and the 2 times x does give us 2x. We can move them to the front. They don't have addition and subtraction with them, so we can multiply those terms together. Now we're going to look at what's in common on top and bottom. Well, x minus 5 and x minus 5. X minus 6 and anything else. So we have 2x and 7x, yes? Well, we have 7 times x and 2 times x, yes? So we do have x over x. X over x reduces to 1. These actually cancel out completely. Because we are very much used to being 7x and 2x, but they divide out. They divide out completely, leaving us with 7 over 2. The only way they wouldn't divide out completely is if one of them had an exponent greater than 1. Because if we had x squared over x, it would reduce to x on top. Or if it was x over x to the third, we'd have x squared on bottom. Does that make sense? If not, please ask. So we good with everything so far? Now again, I said that our keep, change, flip was the one main difference between multiplication and division. And then I added kind of a subnote saying that really there's 2. And the other one, I'm going to erase this here for writing room, comes with our restrictions. Restrictions, because again, we said the denominator cannot be 0. We cannot divide by 0, correct? So, when we look at this here, the 2 places, well, let me go back to the top. I'm going to erase all this here. So, now, I'm doing this here so we can see it. Okay. I went on and factored it, because this is where we got factored. It's just not flipped. The second one's flipped. We're still with division. If we're looking for restrictions here, denominators. One of them is x minus 5, yes? We can see that. That's fine. Set it equal to 0. Solve. So when x is 5, it will make this denominator be 0. So I'll put the list over here. X cannot be 5. Because if x is 5, that one's going to be 0. Well, we could also say the same for this one here. Because if x is 5 for that one there, it would give us a denominator of 0. Does not work. Here, another denominator. So set x minus 6 equals 0. Solve. X is 6. So it tells us x also cannot be 6. We're good with those. Those make sense. I'm going to tell you also that x can't be 0 for this one here. And this seems like an odd statement. And I think it's going to be easier to see this than me just explaining it. Because x cannot be 5 and x cannot be 6 makes sense. We can see that. We get a denominator of 0. I'm going to plug in 0. So in the first one, we get 7 times 0 over 2 times 0 minus 5. Numerator, we have 0 times 0 minus 6. 0 minus 6 times 0 minus 5. Numerator here is 0, 2 times negative 5. Here, 0 times 0 minus 6. That whole thing 0, we're good with that there. Negative 6 times negative 5. Need a little more page. Well, here, 0 over negative 10 divided by 0 over negative 30. Well, what's 0 over negative 10? 0. 0 over negative 30 is 0, yes? But what operation do we have right now? Division. So even though 0, which made the numerator of the second one specifically, it ended up being both, 0 made the second expression become 0, yes? And since we're dividing, it forced us to divide by 0. And that's the other big difference, is that when we divide expressions, this entire expression cannot become 0. Because if it does, because we're dividing, we have now divided by 0. That's the other big difference. But we're not going to spend too much time on that part. I want us to focus more on the actual dividing than putting in the restrictions. Let's look at this here. Again, keep, change, flip. Before we do anything else, keep, change, flip. Because it is very tempting to just start factoring before we get it set up the way we need to. And I've seen it several times that we started factoring and then multiplied and kept going. We forgot to apply our division property. Because once we keep, change, flip, then we can go on and start factoring. And 11x is nice. It's already simplified. What other ones are nice to factor it on this here? 3x minus 9, because it has a greatest common factor of 3, leaving us with x minus 3. And then the next one that's nice is x squared minus 5x. It has a greatest common factor of x, leaving us with x minus 5. And it does give us a lot of hints now at what the last one's going to factor to be. Because it'd be nice if we have an x minus 3 or x minus 5, yes. 15 is positive, so the signs are the same and they match the sign of the middle term, negative and negative. Factors of x squared are x and x, 15. And it does work out, x minus 3 and x minus 5 are indeed the factors. Yes. Now, one thing I've mentioned, I think I mentioned this before, normally we wait to the end to simplify, yes? Do we have a common factor already before multiplying? Yeah. There's nothing that says we can't go on and simplify at this point. So we could simplify that there, leaving 11x times x minus 3 and 3x times x minus 3. Multiply them out. Yeah, and we could. Because when we multiply together, all we're doing is putting the numerators together, denominators together, and then they simplify. X minus 3s are gone. X's are gone. So, yes. So 11x over 3x, yes? What we're saying, guys, let's focus up here. In the numerator is that I have 11 times Rx. And in the denominator, I have 3 times Rx. Which is the same as saying 11 over 3 times x over x. We're just breaking it apart, yes? X divided by x is 1. So this reduces to 1. So I'm going to be tedious in how I'm writing this, because we can say 11 over 3 times 1, which is 11 over 3. So that term reduces out, because I think what you're trying to do is stick it with addition, subtraction. Because when we add or subtract, we're talking about the numbers. And to kind of flesh that out, because 11x minus 3x, greatest common factor between these two is x, yes? So if I remove it, I'm left with 11 minus 3. 11 minus 3 is 8. 8 times x is 8x. But we're very much in the habit of 11 minus 3 is 8x. We jump to it. I think hopefully that explains. Kind of see the difference. Questions on this here? And so far, the numbers haven't reduced because, well, they aren't divisible. keep, change, flip. Keep, change, flip. Yes. Keep, change, flip. Yes. Yes. 5x minus 20, we'd factor out 5, leaving us with x minus 4 times. Which one do we want to factor next? The bottom one, x squared minus 2x. We can factor out in x, leaving us with x minus 2. Almost. 4 is part of the answer. So negative, negative, x and x, and yes, 2 and 4. Now at this point here, yes, if we wanted to mark out the x minus 2 and x minus 2, we can. Yes? Well, as we've kind of said already, when we multiply, we're really making those all 1. So there's not a whole lot of reason for us to rewrite the whole thing if we don't want to. X minus 4 and x minus 4. X and x, leaving us with 4, but it's over 5. 4 over 5. Questions on this here? The only thing more frustrating is when it reduces to 1. Where it's just 1 is the answer. And you're dealing with cubics, so our sum and difference of perfect cubes, factoring by grouping, you're doing all this complex factoring. And then it reduces to 1. The only thing I found more frustrating than that is I've done this myself. I didn't know where to go for a math problem. So I started doing different things I knew could work and different processes and operations. Started on the top of a piece of paper, worked all the way to the bottom.
Oh my gosh.
Flipped it over. And you got to think it was either 3/4 of the way down the back of the page. And I was staring at what I had, and I'm like, this seems very familiar. I flipped the page over, I was back to where I started. So everything I had done on that page had undone itself, and I was back at the starting problem. So I'm like, that was frustrating, wasteful use of a piece of paper. And at that point, I just went and talked to the professor. It's like, I don't know where I'm going. Please help. Now, if we look at this one here, keep, change, flip. Keep the first one the same. 4a squared minus 1 over a squared minus 4. We're going to flip the second. A minus 2 is now on top. 2a minus 1 on bottom. All right. Well, a minus 2, let's start there. A minus 2, there's no greatest common factor. The degree is 1. That's as simplified as it gets. Anything else? 2a minus 1. Well, both of those are nice. Both of those are probably going to be helpful. A squared minus 4. Difference of perfect squares. A squared is a and a. 4 is 2 and 2. So since it is a difference of perfect squares, we get a plus 2 and a minus 2. That's nice. Numerator, 4a squared minus 1. It'd be nice if it's also a difference of perfect squares, yes? What times itself is 4a squared? Well, we'd have 2 and 2 for 4, and a for a squared. So if this is a difference of perfect squares, we would have 2a and 2a plus and minus, yes? Now the deciding factor is what times itself is 1. 1. So 4a squared minus 1 is a difference of perfect squares. It just factors to 2a plus 1 and 2a minus 1. And now we just need to multiply these together. And what simplifies out? Well, 2a minus 1 and 2a minus 1. A minus 2 and a minus 2. Almost. Plus instead of minus. Because we canceled out the minus.
Well, I have the plus. I don't know why I said minus.
Yeah, but that's it. Yeah, so just change. Yeah, because here you crossed out the plus instead of the minus. So I would fix that on your paper that way. When you go back and look at it, you don't confuse yourself of what happened. Questions on this here? We good with these here? Let's look at this one here. So I'm trying to remember how many we have left. I don't think we have that many. You know what? I want to do this one. All right, guys, we're skipping 48, 45, 43. I know it started with a 4. Looking at 52. All right, guys. All right, guys, focus in. Keep change flip. So the first one is going to stay a cubed plus 4a over a squared minus 16. Yes. The numerator is now a squared plus a minus 20 over a squared plus 8a plus 15. So yes, out of all three of these, we do see that the numerator of our first expression, a cubed plus 4a, has a greatest common factor of a. And if we factor it out, we're left with a squared plus 4. Now the next one we can do is indeed a squared minus 16. Is the difference of perfect squares, yes? Which would give us a, guys, a plus 4 and a minus 4. Difference of perfect squares, a squared minus 16. Now we do need to factor the other two. Do we want to, there's no common factor between a squared plus a and negative 20, or a squared plus a, 8a plus 15. So top and bottom, no greatest common factor. Which, a squared plus 8a plus 15. Since the third term's positive, our signs are the same. Match the sign of the middle term. Only factors of a squared are a and a. Factors of 15, 1 and 15, or 3 and 5. 3 and 5, if we did check this here, we would get a middle term of 8a. So those are the correct factors. The numerator, last one, third term's negative, so our signs are opposite. Factors of a squared are a and a. Factors of 20. 2 and 10. 5 on the plus, 4 on the minus, because with 5 being plus, we do have a greatest common factor, or a common factor of a plus 5, and those would cancel. We can also multiply these, connect them, and also have what in common? A minus 4 and a minus 4. And that's everything we have at this point. So the numerator is a times a squared plus 4, and the denominator is a plus 4 times a plus 3. Now, a plus 4, a plus 3, the degree for both of those is 1, because the biggest exponent attached to the variable is 1. A squared plus 4, the degree is 2. So there is a chance it does factor, but we have two things. A squared is a and a, 4 is 2 and 2, yes? So is this a difference of perfect squares? No, it is a sum, but we don't have a sum of perfect squares formula. So it is not factorable. This is the final answer. Questions on this here? And this problem, like the bigger ones we had the other day, was from a college worksheet I found online. Yeah. So, is this anything harder than what we did? No. It's just a little more factoring. We get a little bit odder terms, a squared plus 4, but it is the exact same thing. I'm going to move on to our last set of examples. That's these here. We want to find the quotient for this here. And always, our first step should be to keep, change, flip. What's the denominator for our second expression? 1, which means our new numerator is 1. And the denominator is our 3x squared plus 5x. Out of the two parts of our rational expressions that are nice, one of them is the 4x squared, and the other is 1. Right. Now we need to factor the other two. Which one do we want to factor first? We can go there. We'll go the other way in a minute. 6x squared plus x minus 15. Since the third term is negative, our signs are opposite. Factors of x squared, or 6x squared, you'd have x and x. Now our factors of 6 are 1 and 6 or 2 and 3. We can start with 2, 3. Factors of 15. 15, 3, and 5. Which one do we want to use? We can do 3 and 5. We can't put the 3x and 3 together because they would have a greatest common factor. And our 6x squared plus x minus 15 does not. Now when we check this here, just to make sure, 2x times negative 5, negative 10x. 3 times 3x is plus 9x, giving us negative x. We need positive x. We need to flip signs. Now that brings us to our last part of this expression to factor, our 3x squared plus 5x. There's the greatest common factor of x. So when we factor it out, we're left with x times 3x plus 5. We do have something in common on top and bottom. And at this point here, guys, we can cancel out 3x plus 5, leaving us with 2x minus 3 on top over 4x cubed, because we have an x squared and we have x. So it gives us 4x cubed. And that's done. Because there's no other way to simplify it. Because the only other way we could is if the numerator had a greatest common factor, we could pull out and simplify. Because 1 times 2x minus 3 is 2x minus 3. If everything in the numerator did simplify out, if we did have 2x minus 3 on top and bottom that canceled, then we would indeed write the 1. If everything simplifies out, then we fill that in. We have 2 different problems left. Do we want to look at this one here or the next one? Because let's do one more. Yeah. Let's look at this one here. Keep. Change. Flip. So the numerator is now 1, the denominator is 2x squared plus 2x. So, guys, so 2x squared plus 2x, we'll start there. There is indeed a greatest common factor of 2x plus 1. Anytime something factors out completely, it reduces to 1. Because all we're doing is dividing each term by 2x. So 2x squared divided by 2x, 2 over 2 is 1. X squared over x is x. 2x over 2x is 1. Now the last thing we need to factor is 6x squared plus 4x minus 2. There's a greatest common factor of 2. We need to factor it out first, which will give us 3x squared plus 2x minus 1. Air pressure. Because when the door at the end of the hallways opens, because it lets air in. So as that air flows in, it pushes the existing air molecules in the room forward. And since the door was partially closed as those collisions happen, it pushes on the door. And since the door was pretty much shut, it closes it all the way. Since the third term is negative, our signs are opposite, positive and negative. We look at 3x squared, well, we will have x and x, yes? And the factors of 3 are 3 and 1. Now, we are hoping something matches with the bottom of the fraction, yes? Well, the only expression we have in the bottom of the fraction in parentheses is x plus 1, yes? So, I'm most likely not going to put the 3 with the plus. Because if I did 3x plus a number, I can't match it with the bottom. Factors of 1 and 1. If it is this setup, we do have x plus 1 on top and bottom. Now we can check and make sure that we do get 2x. X times negative 1 is negative x. 1 times 3x is plus, which does give us a positive 2x. Now, we can join these, and one thing we do see in common is x plus 1 and x plus 1. Is there anything else in common? Because we do have 2 over 2, yes? I'll do this in 2 ways so we can see it, because one is we can leave that 2 there and say 2 times 3x minus 1. Over, we can multiply these two together. 5 times 2 is 10. X times x squared is x to the third, yes? So our 2 over 5, or 2 over 10 becomes 1 over 5 x to the third. Okay. Other root. I go on and say that these are canceled out, which leaves us with 3x minus 1 on top. 5x squared times x is 5x cubed. Same exact thing, I just didn't put parentheses around the numerator. So we can get there either way. I'll put the parentheses so it looks a little more similar, but those are the exact same. Questions on this here? That's it, 28 through 34. I threw 28 in. If you notice, I think we did 28 only is single terms. Yep, so there's not any addition, subtraction. Flip it, multiply, simplify. Yeah, there's not anything more to it. We just don't have sets of parentheses. So as we did with the monomials at the start with multiplication, same thing. Flip, multiply.